Hello guys, welcome to tangent and normal for circle. So tangent is basically a straight line that touches one point of the circle, and normal is the line which is perpendicular to the tangent. So let's get on to the equation of the tangent and normal to the circle. So there are some ways to figure out the equation of tangent for the circle. So one is by doing derivatives, because tangent is basically the slope of the circle or of the curve, and derivatives is of the slope. And here let's see the equation of the circle at the origin, which is x squared plus y squared equals to r squared. Now here let's just differentiate both sides with respect to x. You'll get 2x plus 2y dy by dx is equals to 0, because the radius of the circle is always constant. Now we can just divide both sides by 2, get rid of this, and we want to find dy by dx. And simply dy by dx, which is the slope, is equals to minus x divided by y. Now this is for the general form, but what about, let's say, at a point on a circle x1 comma y1. Very bad drawing, I know, but it is what it is. It will be x1 y1. Now let's use the equation of the straight line formula, which is y minus y1 is equals to m x minus x1, and simply put in the value of m. Y minus y1 is equals to minus x1 y1 x minus x1, and it's just algebra from here. Y1 minus y1 square, and we get this over here, and we can rearrange this. So we have x1 plus y1 is equals to x1 square plus y1 square. Well, from here we can actually simplify further, because instead of x and y, we can rewrite it as x1 square plus y1 square is equals to r square. And as you can see, these two are the same. So therefore the equation of the tangent at a point x1 comma y1 is this over here. Now I'll show you how to do it kind of geometrically, which involves a little bit of calculus. So let's get on to it. So let's say you have a circle over here, and before you want to find the tangent, let's find the secant first, or a line passing 2 points. Because here you can use a little bit of calculus. As these 2 points get closer and closer to each other, they eventually reach a very small point. They reach a point where they are so close to each other as if they are one point, and then they become the tangent. So let's say this is x1 comma y1 and x2 comma y2, and here we know the slope will be y2 minus y1 x2 minus x1. So we just have to figure out what this is equals to. Now you don't really want to go to the equation of the circle and find that y2 is root r square minus x1 whole square. So let's move on to the equation of the circle. For x1 it will be x1 square plus y1 square is equals to r square, and for this it will be x2 square plus y2 square equals to r square. As you can see, they are both equals to the radius square, so let's just equate them. x1 square plus y1 square is equals to x2 square plus y2 square. Now we want to find y2 minus y1, and as you can see we have y2 square y1 square, and we also know a square minus b square is a minus b, a plus b. So let's do some rearrangement. So y2 square minus y1 square, moving that there, is equals to x1 square minus x2 square, moving that there. And we can also obtain x2 minus x1 like this. So this is y2 minus y1, y2 plus y1, and this is x1 minus x2, x1 plus x2. So we have y2 minus y1, and we want x2 minus x1, right? But we only have x1 minus x2. Well, it's simple, just take the negative common. So when you do that, this is the same as minus x2 minus x1, and just divide out that on both sides, you will have this, and the minus will stay over here, and you'll have x1 plus x2 by y2 plus y1. Now, this is the slope of the equation of the tangent, and you can proceed from there. However, you can make it easier for yourself by seeing that when these 2 points are very close to each other, they become the tangent of the line. And when that happens, basically this point will be the same as that point. Meaning x2 approaches to x1 and y2 also approaches to y1. So we'll have the slope is equals to minus x1 plus x1, which is 2x1, and below also 2y1. So the 2's cancel, giving minus x1 by y1, which is the same as before, and you have to use the equation of tangent again and you'll get the same answer because this is the same slope. And let's move on to the normal. Now, from the definition of the normal, it is just a line perpendicular to the tangent, meaning its slope will be the perpendicular slope of that of the tangent. So we know that the slope of the tangent is minus x1 by y1, and that means the normal's slope will be minus 1 by m, which is minus 1 by x1 by y1, and minus minus cancels, so m prime will be y1 by x1. Now again use the equation of straight line, and you'll have m prime over here, substitute that in, y1 by x1, x minus x1, and this will be x1y minus x1y1 is equals to xy1 minus x1y1, and there two are the same, just cancel them and move on to the right hand side. You'll have xy1 minus yx1 is equals to 0. So that is the equation of normal at a point x1, y1 on the circle. Now we're still not done, because if you see the equation of circle, you'll see that it kind of has two formulas. One is the center and radius formula, which is x minus h whole square plus y minus k whole square is equals to 0. Or in our case, we have another formula for the circle, which is the general formula, x square plus y square plus 2gx plus 2fy plus c equals to 0. Now, you can again find a tangent using those two ways, either using derivatives or secant and then just approaching them, but they both give the same slope anyways, so I'm just going to use derivatives and differentiate both sides with respect to x. So I'll have 2x plus 2y dy by dx plus 2g plus 2f dy by dx, and c is a constant, so it will be equals to 0. I have 2 on all of these terms, so divide all both sides by 2. These 2 will cancel, and I just want to isolate the dy by dx since that's what I'm trying to find. So I'll have dy by dx, and I can take some things common. So here I'll have y plus f is equals to, and move this and that to the right hand side. So I'll have minus x minus g. That means the slope dy by dx is equals to minus x plus g by y plus f. Now again, for a point x1, y1 on the circle, it will be x1, y1, and put that in the equation of the straight line, which is this over here, and put the value in. You'll get y minus y1 is equals to minus x1 plus g by y1 plus f, x minus x1. So this may look a bit crazy, but at the end of the day, it's just simple algebra. So let's move that over here, and when they multiply, they'll give y1 plus fy minus y1 square minus fy1, which is equals to, here this minus I'll put inside over here. That means this will become x1 minus x, and these two will multiply, giving x1, sorry, this is x1 whole square minus xx1 plus gx1 minus gx. And I'm just going to move everything to the left hand side and see what I can come up with. So I see this, I'll put it over here, xx1 plus yy1, and I also have minus x1 square minus y1 square, and I'll also have here y1, and I'll just put these two over here, plus fy minus fy1, and these go to the left hand side, become minus gx1 plus gx, and this equals to 0. So I don't really seem to get anything over here, but I notice one thing. This minus x1 square minus y1 square, I can take that common, and x1 square plus y1 square, that seems a bit familiar. Is it just the radius square like we did before? No, because in this case, if you have x1 square and y1 square, it will actually be all of this over here. And as you can see, this is a general formula and that was a different formula, so don't confuse them. And from here I can obtain an equation for x1 square plus y1 square, which is this over here. But as you can see, we have a minus over here, so just take the negative on both sides and this will actually cancel. So we know what this is, so substitute that over here, and as you can see, we can simplify a few things. So we have the gx1 and the gx1 and the fy1 and the fy1. So we'll have xx1 plus yy1, this is plus gx1 plus fy1 plus c plus fy plus gx is equals to 0. And this is actually the final equation. You can't go further, but to make it easier and simpler, you can take some things common, and finally you'll have this over here, which looks a bit nice, which is actually crazy but still nice. And for the normal, well, you can also do that, and I'm going to do it over here again. So for the normal, it's the same thing as before. Its slope will be just the perpendicular slope of that tangent, and this will be minus 1 by minus x1 plus g by f plus y. Little bit of mistake over here, but it's fine. Cancel the minus and you get m prime is equals to y1 plus f by x1 plus g. And again, put that into the equation of straight line and simplify, which is just another complex algebra you'll have to do, but let's get on to it. Over here, just put that in. You'll have y minus y1 is equals to y1 plus f by x1 plus g, x minus x1, and just distribute. So yx1 plus yg minus x1 y1 minus gy1, this is g, is equals to y1x minus x1 y1 plus fx minus fx1. And I can see that these two can be cancelled, and I'm going to move everything to the right hand side this time. So from here I'll have xy1 minus yx1, and this will go over there, minus gy plus gy1, and I'll simply have fx minus fx1 is equals to 0. Now this is the final equation, but like the previous one, let's make it nicer. So we'll have xy1 minus yx1 minus g, take that common, or I'll take plus g common, y1 minus y plus f x minus x1 is equals to 0. There we go. This is the tangent and normal to the equation of the circle. But there's one thing more. The length of a tangent from a point to the intersecting point or the touching point to the circle. And this one is actually a bit interesting, so let's do it over here. So let's say we have a circle over here and a tangent from a point x1, y1 to this point over here, t. We want to find the length pt over here. Now we're taking the equation, the general form, this over here, meaning the center will be minus g minus f, and the radius right here will be root g square plus f square minus c, like this. And one thing we know, the radius and the tangent are perpendicular to each other. And let's just complete this triangle over here. And as you can see, we simply have a right angle triangle, and we can use Pythagoras theorem. So we'll have OP square is equals to OT square plus PT square, and we want to find PT. So PT will just be root OP square minus OT square. Now let's find what OP square is. For OP, you can just use the distance formula, which is root x1 minus g. So sorry, minus g, which will be plus x1g whole square plus y1 plus f whole square. Now this will be root under all of this, but when you square both sides, the root will cancel, giving this. And for OT square, here you don't have to do anything because you already know the distance. It is just g square plus f square minus c, like this. And just subtract those equations and you'll have this. And let's just open these whole squares. So we'll have x1 square plus 2gx1 plus g square plus y1 square plus 2fy plus f square minus g square minus f square plus c. And this, then that will cancel, this and that will cancel. And over here you'll have x1 whole square plus y1 whole square plus 2gx1 plus 2f, this should be y1 plus c. And that is the value of OP square minus OT square. That means PT is just the square root of that. And we have found our length of the tangent from a point. There we go. So this length over here is just root x1 square plus y1 square plus 2gx1 plus 2f1 plus c. So you'll notice that this is just the equation of the circle, but for a point x1 comma y1, and it's just a square root version of that. So I had almost forgotten this equation of tangent in slope form. So let's have the equation of tangent be y equals to mx plus c. Now what we want to do is we want to solve for this c right here, because we already have mx, and this c we want that also be in some kind of slope form. So we have the equation of circle y square equals to r square minus x square, and let's just put this value in. That means for a circle and this tangent over here, this point over here, we're solving for this point. So this will be mx plus c whole square is equals to r square minus x square. So this is m square x square plus 2mxc plus c square is equals to r square minus x square. Now let's make it into some kind of a quadratic form. So we have m square x square, minus goes over there, plus x square plus 2mcx plus c square minus r square. This goes to 0. And right here we can take the x square common, so we'll have m square plus 1 x square plus bracket 2mc into x plus c square minus r square is equal to 0. So as you can see, this is in the quadratic form in terms of x. And right here you don't have to solve for the two values of x, because it is a tangent. That means there is only one point of contact. That means there is only one value of x. So you don't have to use the quadratic formula at all, but you have to use the property. If in a quadratic form x has only one value, then that must mean that b square is equals to 4ac. So what this is let's say this is in the form ax square plus bx plus c is equals to 0. Then this b square is equals to 4 into a into c. So let's just compare the a, b and c to this right here. So our b is 2mc square, that is equals to 4. A is m square plus 1, and our c is c square minus r square. And now let's just expand this. So this is 4m square c square, this is 4, and distribute this, it is m square c square minus m square r square plus c square minus r square. And this 4 and 4 cancels, so we're going to have, here we'll have m square c square is equals to m square c square minus this, all of that, and we can also cancel this over here. So what we'll get is 0 is equals to minus m square r square plus c square minus r square. So the whole point of this is we're trying to find this c over here. So we have just to isolate this c. So c square is equals to, put everything to the right hand side, m square r square plus r square. And finally we'll have that c is equals to, take r square common, r square 1 plus m square root whole over. So this is, but we have to put a plus minus over here, and right here you can distribute the square root. So we'll have square root of r square into the square root of 1 plus m square. This square and root will cancel, so the r just goes outside, and you'll have 1 plus m square. And now substitute that value in here, and finally you get the equation of tangent as y is equals to mx plus minus r root 1 plus m square. And m, of course, is the equation of tangent over here, and this is what we're trying to find. Now let's talk about the condition for tangency. So what are the conditions for a straight line to be tangent to a circle? Well, we discussed earlier that c has to be equals to plus minus a root 1 plus m square, or not a, r, which is the radius, and here c is just the y-intercept of the tangent line. And this is for the equation of circle at the origin. But what about at any equation at all? Is there a definite condition? Well, yes. You have to use one fact about circle and tangency. So if this is a tangent, then here the angle between the radius and tangent we know is 90 degrees. What that means is this radius and the tangent line are perpendicular to each other. And in fact, in mathematics, we thankfully have a formula to find the perpendicular distance. Well, a perpendicular distance of a straight line to a point. And the point in our case for this circle is the center, h comma k. Let's say that this equation of line is ax plus by plus c. And here the center is h comma k, and the radius, which is the perpendicular distance from this straight line, is equals to r. So perpendicular distance is equals to r. And here the perpendicular distance formula is modulus or plus minus ax1 plus by1 plus c by root a square plus b square. This is the perpendicular distance formula. And a and b are the coefficients of x and y of this line, and this x1 comma y1 is a point from that straight line at a perpendicular distance in which we want to find that length segment, and in our case is the center. And this perpendicular distance, in our case the tangent line, has to be equals to the radius of the circle. So that means the perpendicular distance, or this, is plus minus a, and our x1 is h plus b, and that is k plus c root a square plus b square is equals to r. And a good thing about this is from here you can square both sides, and you'll get ah plus bk plus c whole square. By this root will cancel when you square them, so this will be, this is equals to r square. And this is very useful because here typically we will have x minus h whole square plus y minus k whole square is equals to r square, and we can simply put down the value, but otherwise this is fine as well. And this is the condition. A line has to fulfill this right here to be a tangent to the circle. So if you guys learned something new, please like and subscribe. Thank you.